Have you ever wondered how a clock can tell time without batteries or electricity? It's a question that takes us back to the roots of timekeeping. Mechanical clocks are marvels of engineering that have been keeping time for centuries. These intricate devices are a testament to human ingenuity and craftsmanship. They rely on a fascinating interplay of simple machines and precise movements. Each gear, cog, and spring works in harmony to measure the passage of time. Imagine a world without digital clocks or smartphones. In such a world, mechanical clocks were the pinnacle of timekeeping technology. How would we measure time? Sundials and water clocks were early attempts, but mechanical clocks revolutionized our ability to track hours and minutes accurately. Mechanical clocks provide a glimpse into the ingenious solutions of the past. They are not just timekeepers, but also pieces of art and history. These clocks don't need batteries or outlets. Instead, they are powered by winding a spring or using weights. They harness energy in a different way, using simple physics principles. The escapement mechanism, for example, controls the release of energy to keep the clock running smoothly. Understanding how they work is like unlocking a time-traveling secret. Each component has a specific role, and together they create a symphony of motion. Let's delve into the captivating world of mechanical clocks and uncover the secrets behind their enduring appeal. From their historical significance to their mechanical brilliance, these clocks continue to fascinate and inspire. At the heart of every mechanical clock lies a source of stored energy. This energy is what powers the entire mechanism. Think of a tightly wound toy car. The wound-up spring stores energy. This energy releases as the car moves. Mechanical clocks work similarly, often using a wound spring or a system of weights. Winding the clock or raising the weights stores potential energy. This stored energy is ready to be released slowly and steadily. This controlled release of energy is the key to the clock's ability to measure time. The stored energy needs to be released gradually and consistently. This is where the gear train comes in. A gear train is a series of interconnected gears of different sizes. They work together like a system of pulleys. As the stored energy turns the first gear, it sets the entire train in motion. Each gear in the sequence rotates at a specific speed, determined by its size relative to the others. This carefully calibrated system controls the rate at which the stored energy is released, ensuring the clock keeps time accurately. Section 4. The heart of the clock, the escapement mechanism. The escapement mechanism is the heart of a mechanical clock. It's responsible for both regulating the release of energy and counting the seconds. This intricate mechanism acts as a gatekeeper between the stored energy and the timekeeping components. Imagine a small gate that swings back and forth. With each swing, the escapement mechanism allows a precise amount of energy to pass through from the gear train. This controlled release is what produces the characteristic ticking sound of a mechanical clock. Section 5. Keeping the rhythm, the pendulum or balance wheel. In this section, we delve into the heart of timekeeping mechanisms. The escapement mechanism needs a regulator to ensure the ticking remains consistent. Without this, the clock would lose its accuracy and fail to keep proper time. This is where the pendulum or balance wheel comes into play. These components are crucial for the clock's precision. A pendulum is a weight that swings back and forth at a constant rate due to gravity. This consistent motion is what helps regulate the clock's timekeeping. Alternatively, a balance wheel is a weighted wheel that oscillates back and forth, regulated by a delicate spring. This spring ensures the wheel's motion remains steady and precise. Both mechanisms work in tandem with the escapement to maintain a steady rhythm. The escapement releases the clock's gears at precise intervals, controlled by the pendulum or balance wheel. They ensure that each tick of the clock represents an equal interval of time. This precise regulation is what allows clocks to be reliable instruments for measuring time, ensuring that every second is accounted for accurately. Section 6. The symphony of time hours, minutes, and seconds. Now, how does the clock translate these ticks into hours, minutes, and seconds? This process is a fascinating dance of precision and engineering. The answer lies in a series of additional gears and wheels connected to the escapement mechanism. Each gear has a specific role in this intricate system. As the escapement ticks, it advances a series of gears. These gears are meticulously designed to ensure accurate timekeeping. These gears are calibrated to represent seconds, minutes, and hours. Each gear turns at a different rate, corresponding to the passage of time. The movement of these gears is translated onto the clock face by the hands. The hands move in a synchronized manner, displaying the time accurately. The intricate interplay of all these components results in the harmonious display of time that we see on the clock face. It's a beautiful symphony of mechanical precision. We take it for granted, but it is a marvel of engineering. Each tick and tock is a testament to human ingenuity and the quest for precision.